Okay. As defined by the plane of our solar system. Whoa, what? Okay. These equations produce what is called a plane curve. Our solar system sits, essentially, for our purposes in this problem, on a flat surface. Now, I know it's clearly three-dimensional. We have some strange orbits that tilt a little bit, but for the purpose of what we're dealing with, let's just say it's a plane surface. As defined by the plane of our solar system, the lateral path of a comet for t greater than 1 is modeled by this equation, and the forward path is modeled by this. Lateral means side to side. Now, if you're looking at our solar system from outside our solar system, then, not that anyone's been outside our solar system, but if you were, then, who defines what's lateral and who defines what's forward? You can think of this as horizontal and vertical, but, that's essentially what we're dealing with here. I tried to choose my words wisely as I worded this problem, knowing that there is no horizontal or vertical in space. That's really what I'm saying. So if it sounds wordy, that's why. It's years of watching Star Trek. Create a function by eliminating the parameter and sketch the path of the comet. So let's actually jump to the end and sketch the path of the comet. And fortunately for us, graphing calculators can do parametric functions. Oh, who knew? Well, I knew, and now I'm telling you. So here's what we're going to do. Follow closely. We want to graph something that is parametric. Up until this point, everything we've done has been a function. Don't do what I'm doing right now. If you press y equals, you'll have functions. I don't want functions. I want parametric. Now follow. Press mode. Scan through there. You'll see something that looks like what we're doing, and it's this. Switch from function to parametric. Okay? Once you're here, you have it highlighted. It's ready to go. You're going to quit. Second and quit. It's like an escape key. And then we're going to type y equals. All right, I have a bunch of stuff in here from previous things. If you do, clear it out. You probably don't. There we go. All clear, all clear. Notice we have x1t and y1t, x2t and y2t. We're just going to fill in x1t and y1. It used to be like y1, y2, y3. Well, now it's x1 and then y1, and they are functions of t. Okay, the t is the same button for the alphabet. You could use is the 4 button, or you could press this. You ever wonder why it was a x, comma t, comma theta, comma n? Because of all the different modes you could use. Just saying. All right, fun to know. 2 divided by the square root of t minus 1. And neat that they said that t is greater than 1 because, well, you can't take the square root of a negative number. You can if you want to play with imaginary numbers, but anyway, that's what you get. And then over here you'll have t divided by, and then parentheses, because we need it, t minus 1, because we're grouping that entire expression together. Okay, I want to graph this thing, and I'm going to set my window accordingly, and I can kind of see from what they provided for me that my x values will be just sort of standard-ish, like negative, 5 to 5, negative 5 to 5 for the y's. But let's press window anyway. And there are parameters for the parameter. Let me rephrase that. There are restrictions on the parameter as well for the window. The minimum value for this problem needs to be 1, and the maximum, well, it can go forever. So let's let it go 100, I think is reasonable. And how much is t going to step by? See, when it does this, it computes it like step by step by step. And this kind of defaults to that. I'm going to make it like 0.01. It might slow it down a little bit, but it'll work. X minimum, let's go negative 5. X maximum 5. X scale, that's what that stands for, was 1, so it's scale of 1. Y minimum negative 5, Y maximum 5, Y scale is 1. Okay, I'm going to press graph. There it goes, there it goes, there it goes, there it goes. It's going, it's going, it's going, it's going. It's going, it's going. It's trying to go. That's all it's going to get. Oh, no, it's still going. All right, I am going to begin while this is still thinking. I know it's thinking because that circle is spinning. I am going to go ahead and isolate the parameter here and plug it in here. That's exactly what we did in the previous problem. We solved for t, we plugged it into the other one. Totally fine. It'll create a function. Now, if you're looking at that saying, that looks like a parabola, I'll go ahead and tell you it actually really is. So let's do it. What color should we use? I wish I had dice, I'd roll them. Let's go purple again. So x is 2 over the square root of t minus 1. We're going to try to solve, I'm going to try to talk. We're going to try to solve this for t. So let's cross multiply. X and then square root of t minus 1 is equal to 2. So the square root of t minus 1 is equal to 2 over x. We will square that. We have t minus 1 equals 4 over x squared. And then t is equal to 4 over x squared and then plus 1. Hey, we got t all by itself. Sounds good. All right, we're going to take that and we're going to plug it in for t over here, and it's going to get real sloppy real fast. So y equals t over t minus 1. So y equals t, this expression for t, over t minus 1. Okay, well, there's something obvious in the denominator, so let's do the obvious. And we're going to have, oh, my calculator's still thinking. You can't see it, but it is. 4 over x squared plus 1 over 4 over x squared. I feel like this pen's running out of ink. It's making me sad. Okay, I am bothered by this. It's just making me slightly angry. So I have a wonderful idea that is not my original idea. Let's multiply. Let me pause for a second. This is what we call a complex fraction, where we have fractions on top of fractions inside of fractions and fractions on fractions, and it's nasty. If you multiply every term by the least common denominator, which in this case is x squared, then you will eliminate all the fractions within the fraction, and you'll be left with the big fraction. So here goes. X squared cancels, and I have 4 plus 1x squared over, and then x squared cancels, and I have 4. And I am now left with 1 plus x squared over 4. We'll call it 1/4 x squared. This is the parabola that you see here that it just finished graphing. Now, notice it didn't quite make it to the y-axis. There's a reason for that, but we'll address that maybe later. So we're going to graph this. If I graphed this, obviously I would touch here. And let's see, let's pick another point that I could use. If I plugged in a 2, there we go, that'll work. If I plug in a value of 2 right here, I'd have 4 and then 4, 1, so 2. Plug in a 2, you'd get a 2. Plug in a 3, you'd get 9/4. That's 2.25 plus 1, that'd be 3.25. Plug in a 4. By the way, if I plug in a 1, I'd get 1 1/4. Plug in a 4, I'd get 16, so 4, 5. There, I think that's sufficient. There we go. Isn't that lovely? Okay, but it also said, create a function by eliminating the parameter and sketch the path of the comet. I need to turn the lights back on because I've been sitting here so long that the lights just automatically went off. Or we could finish this one in the dark where it's scary and nothing but the calculator lights up what we're doing. Anyway, sorry, got a little weird there. So I'll finish it like this. This that we can see over here in the dark, this parabola has a restriction on it. And that parabola's restriction is, what color was I writing with? I can't even tell anymore. Where's my purple pen? There it is. That restriction is that I'm only dealing with x values that are greater than 0. So x is greater than 0. Now, okay, this is where things get a little bit tricky. I need some light. Give me a second. Stand in the middle of the room in the motion detector. There we go. Come back on. No more ghost stories. Scary ghost stories and tales of the glories of Christmases long, long ago. Okay. Is x greater than 0 or is x greater than or equal to 0? Well, let's look. I need to fix my graph actually just a little bit, and I also need to deal with the fact that originally, even though this is my equation came from here, which came from here. And in this, I was dividing by something with an x in the denominator. So 4 over x squared. X cannot be 0. So x has to be greater than but not equal to 0. So if you want to get technical, and I apologize that I'm having to back up and fix this, but if you want to get technical about it, this can never touch 0, which, by the way, kind of makes sense from what we saw here a second ago. It kept graphing and getting closer and closer, but it never actually would touch it. Never would. So there we go. We have just created a function, eliminated the parameter. Eliminate the parameter, meaning get rid of t. No t's down here. Solve for t, plug it in the other one, clean some things up. Think about what would be a reasonable domain in this case, and it would not include x equals 0 because of that, for those reasons. So this is our function right here. I should write it a little bit differently. Let's fix that. This is our function right there. There. Ignore that vertical green line.